Sine squared equals a half will lead us to two possibilities. Once we take the square roots of both sides, we should have that sine x, without the square on it, will equal the square root positive square root of 1/2, right? Let me just write this first, maybe. All right, sine of x plus or minus the square root of 1/2, which is the same as the plus or minus of root 2 on 2. Okay, if you just simplify this and rationalize it, you'll see you get this. All right, so that means sine x could be the positive root of 2 over 2, or sine x could be the negative root of 2 on 2. Okay, so we have two different situations to deal with. They're very similar to each other, so the solutions aren't that different. At least the method of solution is not that different, I mean. So let's just look at the first one very quickly. I want to know where x is going to be as an angle that will cause sine to produce root 2 on 2. Okay, so let's just draw a very simple picture here. There's two things to worry about again. There is the reference angle, and there is quadrancy. You figure out those two things, and we'll have everything. Okay, so the reference angle that causes sine to become root 2 on 2 is pi on 4. Okay, so the reference angle is pi on 4. The quadrant where sine becomes a positive ratio is 1 and 2. Okay, so conceptually we need an angle of pi on 4 from the x-axis in two quadrants. Okay, so over here as well, angle of pi on 4 from the x-axis, right? So there's our two pi on 4 displacements from the x-axis, all right? So that's pi on 4. Now I know the actual angle here is 3 pi on 4, I agree, but I'm just saying in terms of reference angle from the x-axis, this is pi on 4. And we know which quadrants to put it in because sine was producing a positive root 2 on 2. Right. So there's what you might say is our two fundamental solutions to this problem. Okay, there's more than these though. So what's going to happen is because there was no restriction on the domain for this problem, it means we have to consider all possible solutions. So therefore it's going to be pi on 4 plus 2k pi. Any pi on 4, and I added 2k pi to it. All right. Just go around or backwards this way how many times you want. It'll end up in the same terminal side again, and it will cause sine to produce this this ratio. So therefore, right now we have solutions pi on 4 plus 2k pi. Right? Again, this is just some number, some integral number of revolutions, right, back to the same terminal side. So to this one, I need the actual angle. The actual angle is 3 pi on 4. Right? You don't want to use the reference angle solely, right? The reference angle happens to be the exact angle here, but over here it's not the exact angle. The true angle is 3 pi on 4. So I also have 3 pi on 4, and again, plus any number of 2 pi repetitions. All right, so this is the solution set, right? This set of angles is the solution set for this particular part of the problem. Now we're going to play the same game with this one over here and see what it produces.